All right, we're going to be covering range and standard deviation. These are all like a form of statistics and a form of using data. And what we see here is just a bunch of numbers, but these numbers would be something where we might collect this data, like we might measure something. You might take a bunch of 5-year-olds and you measure all of them, and then this is maybe their centimeters, not centimeters, but their inches maybe.
Okay.
Or you might take a bunch of go outside and somehow if you were a policeman and you had that little radar gun, you could go and find out how many on our road, how fast everyone was going, and this would be all their speeds or something. Okay, and so you would. This is when you first see it, it looks like just some random numbers that they picked, but these would always be something you would collect by doing some kind of either experiment or measuring something and having a bunch of data. Okay.
Okay.
You have studied mean, mode, and median, and that's a form of just analyzing the data, finding the mean, mode, and median. And today we're going to add to that by doing the range and the standard deviation. Okay? And so I'm going to just start reading here. And it says, a careful look shows that the numbers called data points in set 1 are close to each other. None of them are are more than 4 greater or more than 4 less than 50. So if you just look at it, we have 50 is like the middle. And they even have these in order for us, which is nice. They have 46 down here and 54, and they have them in order. And they're all really tight to each other, okay? Mm-hmm. The data set 2 are spread further apart than each other. One is 25 greater than the other and 14 less than the other. Notice we started clear up here at 26 and jump clear up to 75, so there's a huge spread in them, okay? And so both this range and the standard deviation are going to measure how wide our data is. The mean, mode, and median told us where's the middle of this data. Okay? The median, or the mean was the average. And that's going to tell us the median, we put them all in order and find the middle. And the mode is going to affect our mean and median by having, and if the most, usually when you have a most, it's going to actually kind of tell us somewhere towards the middle also. Okay? But the range and the standard deviation today are going to tell us how far apart things are. Okay? How wide our range is. So the range is very simple to calculate. The range of the set of data is the difference between the greatest and the smallest. So if we look at set 1, the highest is 54 and the lowest is 46. And to find the range, all we do is subtract them.
That's it?
That's it. So 54 minus 46, we're going to have to borrow. Make that a 4. So we got an 8, or a range 8, okay? And then our range for the second one is going to have more of a spread. It goes from 26 all the way to 75. So we're going to take 75 minus 26.
Which is... What in the world? Okay. So 2 plus 6 is 8, 9? That's not right. I added. Bad. Here's it. So that makes 6. And then 6 minus 15 is 9. And 9 and 2 minus 6 is 4. 49.
49. Okay.
I hope that's
all right. So there's a huge, look at the span that set 2 covers a range of 49, where set 1 only has a range or a span or a width almost like of 8. Okay, so now we're going to do something what's called standard deviation. Okay, let's go to the next one. Here's a list of the things we're going to do, but let's read about it first. The range indicates how spread out or concentrated a set of data are, but it does not tell us how closely related the dots are within that range. So in this one, our range told us that we have from beginning to end, we have a span of 8, but it doesn't tell us inside. We could have some on over here. We could have on the number 2. We could have a whole bunch of them gathered really close together over here, but then one jumping way out there. Okay, so it doesn't tell us how closely each of them are, and so the standard deviation is going to help us with that. They may also they may all be close to the center point, with only a few high and low, and very low numbers that stretch out the range, or they may be evenly spaced throughout the range. Do you understand? So we could have them all clustered around the center and then some little ones on the edge, or they could be evenly spaced in there. Okay.
Okay.
Standard deviation measures the variation in a group of data points using an average of the squares of the distance or the deviation between the data points and the mean value. So we're first going to find the average of the data, and then we're going to find out how close to that average they are. Okay? Several steps are involved in calculating standard deviation. It is important that computations be done in a correct order. So, and they're giving you the order right over here. Okay? To find the standard deviation, follow the steps in the box at the top of the next page, which we have up there. Okay? So, we're going to do data set 2. So let me go get that for us.
Can you...
Maybe I have to rewrite it.
Can you, like, get it and then, there it goes.
Here we go. Okay, here we go. Yeah, that's not too bad, actually. I have the line of it. Okay. Okay, here we go. And I'm going to actually erase a little bit here. We don't need that part. No problem. Okay. We're going to do the standard deviation. So it says, number 1, to find the average. And so we might need to get a calculator out. And we'll do that. We'll get a calculator out. All right, so we just used it on the calculator, and we found out that the average was 50. Okay?
Okay.
All right, so then, number 2, subtract the mean from each data point. So we need to take 50 minus 50. And we need to make sure that it stays, so we're going to take 26. We always take this number, and we subtract 50 from it. Then we take the next one.
Oh, that's a long drawn
It is going to be long. 50 minus 50. We always take the average on the bottom, okay? Oops. And 58 minus 50. And 75 minus 50. Okay? So this is going to be... And actually, when you're writing it, it's actually going to be better for you to make sure that you're writing it on top or bottom. But and you're welcome to use a calculator on all of this. Okay, so you're so okay to use a calculator. So this, I think, is going to be negative 24, negative 9, 0 and 0, 8, and 25. You with me so far?
Yeah.
Okay. All right. So then number 3 says square each of these differences. So we're going to take this number here and square it. And again, you're going to be able to use a calculator, so no stress. So 24, and the nice thing about all these negatives are going to become positive when you square them. Okay? So we'll pause this and we'll go do at least the 24 on our calculator. The rest of them we can do on our head. And 25 maybe we'll need to do on a calculator. Okay? So we're going to square all of them now. So here's our next step. We're going to have 576. We're going to have 81. We're going to have 0 and 0. We're going to have 64. And this was 625 when we did it on our calculator. So again, feel free to use a calculator. Okay? Next step, number 4 here says add all the squares together. Okay? So we're going to add these all together. Okay, again, use a calculator. We'll go do that right now. All right, so now we have the total right there. Okay, number 5. Divide the sum by the number of data points. So we got this right here, 1346. We're going to take this 1346 and divide it by the number of data points. How much do we have?
7, I think.
1, 2, 3, 4, 5, 6.
Oh, 6. So I'm not going to count this.
Right. We're the number of data we had, just like we divided by 6 for the average. We're taking the squares and we're averaging the squares. Okay. We squared them all. We found the average. We subtracted them, squared them, and now we're going to add them up and divide by how many there are. There's 6. Okay?
Oh, I counted one of the addition signs. That's why
I got
7.
Right. And so then we can do that on our calculator. Okay, when we did that on our calculator, we get 224.3, but keep all the decimals on your calculator. Okay? Now they want you to, the last step, number 6, is find the square root of this, and this is called the quotient, okay? Find the square root of the quotient. That answer is the standard deviation. So when on your calculator, just take the square root of that whole long thing you have on there. Take the square root of it, okay? Let's pause it and do it, okay? All right, so I wanted to bring this in here to show you that on the calculator, we kept all the decimals when we divided by 6 and then took the square root. So your answer, we're going to do to 2 decimals. And so that's the 2 decimals, and we look at that 7 to see if it goes up or stays the same, and the 7 makes it go up. So your standard deviation is 14.98. What in the world does this tell us? Okay? This tells you how widespread your data is. And it's spread out by an average of 14 or almost 15 for every in between each one. Okay? So when we went back, when we look at the data at the top, the spread between each of them is an average of about 15. Okay? And if you can, we won't do the standard deviation on this one, but if we did, the number would be a smaller number because this only goes 3. There's only a 1 and a 0 in between, a 1 and a 3 in between each of them. Right. And so if we were to do that one, our standard deviation would be smaller, indicating that the data set has the numbers are closer together. Okay? All right. This is a lot of steps. So you're going to, and like I had mentioned before, I'm going to let you write these down on a note card. And then when you're taking a test or a quiz, you can get that note card out. This is the only part of the notes that I'll let you use for your test or quiz because it's a lot of steps.
Yeah.
But I think that once you do this, and since the book is like this, it does, you're going to do 2 today, but you're going to continue to do these over and over. And so you're going to have it in your mind after a while.
Good.
Yeah. And so this is a longer process, but it's actually good for you to know that the word standard deviation and how to calculate it. Okay?
Okay.
All right.